For combining functions, we are always given two functions, in this case f of x and g of x, and we can determine the sum, difference, product, and quotient of the two functions. For sum, if I take f plus g of x, I can find that by just taking f of x and adding g of x to it. This operation makes a new function by adding the two functions together. I need you to understand that this is a new function, that we're creating a different function from the two original functions given. For difference, if I have f minus g of x, I can simply take f of x minus g of x. Again, this makes a new function by subtracting the two functions. For the product, pronounced f times g of x, notice this is a dot, it's not an open circle, which we'll use a little bit later in the lesson. This is f times g of x, which means f of x times g of x. This makes a new function by multiplying the original two functions. And lastly, for the quotient, f divided by g of x can be found by taking f of x and dividing by g of x, given that g of x is not equal to 0. Because if g of x is equal to 0, then that would make this whole thing undefined. Again, this makes a new operation by dividing two of the original functions. We will be finding the domain of our new combined function, and the domain will be the intersection, or all values in common, of the domains of f of x and g of x, excluding any new bad values created by the combining of the functions. And usually this occurs with the quotient of the two functions, where you might have a new excluded value because you divided by a g of x. So given two of these functions, f of x and g of x, I want you to find the new combined functions and their new domain. Now, because we are creating new functions from old functions, we need to consider their domain preferences of the original functions, even if the new functions may look different. What does that mean? Let's talk about this blue function f of x. I would like to know the original domain of f, so that when I add f and g, or subtract f and g, or divide, whatever the combining that I'm going to be doing, I want to take in consideration the values that are excluded from the original problem f. Well, the function f doesn't have any even roots, nor does it have any rational functions, so therefore my domain is going to be negative infinity to infinity for the blue f function. For g of x, I would like to know the domain of g before I get started on combining the new functions. The domain of g is going to be also all real numbers, because we have no even roots, we also have no denominators. So the domain of my blue function is all real numbers. The domain of my green function is also all real numbers. The intersection of the domain, or basically the common values between f and g's domain, is again all real numbers. There's no excluded values for f, there's no excluded values for g, so my domain for my combined functions will start with all real numbers. But, as I said earlier, if we have any new bad values created, then we're going to have to exclude them from this domain. To find f plus g of x, using the definition, I know it's f of x plus g of x. My f of x values that I can substitute in are x squared plus 2, plus the g of x values I can use are x minus 7. So f plus g of x is simply x squared plus x, combining my constants, minus 5. This is my new function f plus g of x. Now my domain of f plus g, I start off with my domain of the intersection of f and g, which is all real numbers. There's no excluded values for my original blue. There's no excluded values for my original green. So I start with all real numbers. Is there any new excluded values? There's no rational functions, nor are there any even root functions in my new combined function, so my domain is still all real numbers. For f minus g of x, using my definition, I have f of x minus g of x. The f of x values I can use are x squared plus 2 minus x minus 7. Notice I put x minus 7 in parentheses because I have a minus here. Because I have a minus, I'm subtracting all terms of g of x, which is why I use the parentheses. Notice I didn't use the parentheses on the first problem, although if I put them here, I still would have got the same answer. So I can reduce x squared plus 2 minus x plus 7 after distributing, and combining like terms, I'm now getting x squared minus x, adding my constants, plus 9. So my function f minus g of x is equal to x squared minus x plus 9. My domain for f minus g, the new function that we created here, I first start with my intersection of all real numbers. So I start with all real numbers because my blue nor my green function had any excluded values. My new combined function doesn't have any problem areas like rational functions or square root functions. So my domain is going to be still all real numbers. There are no bad values that we need to kick out of our party. For f times g of x, using my definition, I have f of x times g of x. My f of x values that I'm using are x squared plus 2 from the definition given above, times the g of x values are x minus 7. I can distribute and get x cubed minus 7x squared plus 2x minus 14. There are no values here that can combine, so my answer for f times g of x is equal to x cubed minus 7x squared plus 2x minus 14. Now I'd like to find the domain for f times g. In this case, I start with my domain of my intersection, which is all real numbers. I have no new excluded values. I have no new denominators. I have no new even roots. So therefore my domain is still going to be all real numbers. For our last example here, I have f divided by g of x. Using the definition, I have f of x divided by g of x. So I substitute in f of x, which is x squared plus 2, divided by my values of g of x, x minus 7. Now, neither of these can be factored or reduced at all, so my function f over g of x is simply x squared plus 2 all over x minus 7. The domain of f divided by g is equal to the intersection, which is all real numbers, but I have to exclude any new bad values. Remember we talked about the new bad values created by combining the functions. Notice we mentioned that it usually happens with the quotient. When we look back at this problem, notice that I have created a new denominator that was not in my original f of x. It was not in my original g of x. It is a new problem area. So I have to find the domain by setting the denominator not equal to 0. X cannot be equal to 7. What am I allowed to include? Everybody except 7. So I exclude 7 and I have all the values to the left and to the right of it. In interval notation, we have negative infinity until 7, union 7 until infinity, which is my new domain for the new function f over g of x. For our next problem, we have two functions again, and we need to consider the domain of f and the domain of g first, before we try to find the domain of any combined functions. Again, if we're thinking about this as the invitations to the party, the blue function has his own party list, the green has his own party list, and when you combine the two parties together, you can only invite those that both the blue and the green are happy with. Plus, when you put it together, you might create some more problems and we have to exclude those from our values as well. So this first blue function, f of x, is equal to the square root of x plus 2, is an even root function, and it has a problem. So x plus 2 has to be greater than or equal to 0, and x has to be greater than or equal to negative 2, which means I can only be negative 2 until infinity as my domain of f. Whereas for my g of x function, there is no rational function here, nor is there any even root function, so for my domain of g is all real numbers. He's going to let everyone come to his party. Whereas the f function only allows negative 2 and greater into his domain party. So what I want to consider is if I'm going to combine the functions or take the domain of f intersect with the domain of g, what would be their new combined domain? If I graphed the blue domain, it would start at negative 2, include negative 2 and anything greater than it. If I graphed the green domain would be everybody. But again, this is a combined party here, and we only want values that satisfy both the blue and the green functions, and the only part that would satisfy for both would be from negative 2 until infinity, because both lines are satisfied in that interval. So all of the combined functions that we're going to find in the next 4 examples have a beginning domain of negative 2 to infinity. Then we have to exclude any new bad values. So looking at our first problem, f plus g of x, the definition tells us we can use f of x plus g of x. My f of x function can be replaced with x plus 2, the square root of x plus 2. The g of x function can be replaced with x minus 4. Notice there's no combining left to do here, so my function f plus g of x is simply the square root of x plus 2 plus x minus 4. My question is there any new excluded values? Well, we've already taken care of the blue function's domain. We know that we have to start with negative 2 to infinity, and the green function's domain by itself, which is all real numbers. But I want to know, is there any new bad values created? Had I divided by anything, do I have anything new that I haven't already looked at? Well, in this case, there isn't any new bad values. So my domain of f plus g is the domain that we started with, the intersection, which is negative 2 until infinity. Again, the new bad values we said were probably going to occur in the quotient, but because there's no new bad values, I can just use negative 2 to infinity for all of my combined functions unless we create a new bad value. For the next f minus g of x, we have f of x by definition minus g of x. Again, don't forget when you do the minus, you want to probably include parentheses there. The f of x is x, the square root of x plus 2, minus in green, x minus 4. Notice I put that in parentheses because whenever you subtract a polynomial, you want to distribute your negative all the way through, which will get us the square root of x plus 2 minus x plus 4. Everyone gets the minus x right. It's the plus that they often forget to distribute the negative to the second term. There's nothing else to be distributed or combined here, so this is my new function that I've created by taking f minus g of x. My domain is going to start with -2 to infinity. These are all the values we're allowed to have from my original two problems. And did I create any new problems? Well, I didn't really create any new problems. I still have the one radical problem, but we've already taken care of that. So my domain is -2 until infinity. To find f times g of x, by definition I use f of x times g of x. The f of x values that I use are the square root of x plus 2 times g of x, which is going to be x minus 4. I can do a little bit of distributing here. I'm taking the square root of x plus 2 times x. I'm just going to go ahead and put the x in front. Minus 4 times the square root of x plus 2. Which leaves me with f times g of x. My new domain of f times g, we start off with the intersection, which is -2 to infinity. Do I have any new bad values that I've created? Well, no, I haven't created any new bad values, which usually happens with the quotient, so my domain is just -2 to infinity. For f divided by g of x, I have f of x divided by g of x. My f of x expression is x plus 2 divided by my g of x expression, x minus 4. There's nothing really to be factored or reduced here, so I have f over g of x is equal to the square root of x plus 2, all divided by x minus 4. Again, I ask myself the question, is there any new excluded values that I have created? We are already deciding that we're starting with our original -2 till infinity because of the intersection of d to g, but is there anything new? Well, yes, there is something new that I've created. Because I divided by g of x, and g of x is in the denominator, I'm creating a rational function, and this is now a problem area that I haven't already considered. So I'm going to take x minus 4 is not allowed to be equal to 0. X cannot be equal to 4. Well, we already talked about we have a domain restriction from my original f and my original g being from -2 until infinity. But now in this purple new combined function, we're saying, well, we have a new problem where we didn't have before. When g of x was all by itself, we didn't have a problem with x minus 4 being in a numerator. But now that we've created a new function, putting g of x in the denominator, we have a problem area. X is not allowed to be equal to 4. So I'm going to come in here and punch out a little hole at 4 and only include the values that are greater than or equal to 2, but not equal to 4. So this new function is coming in and saying, okay, I agree with your party list for the blue, I agree with your party list for the original green, but I'm now including a new domain restriction. I'm not going to invite 4 to my party because he would make the denominator 0 for my new function. So my domain for my f divided by g function is going to be -2 till 4, including the -2, union 4 until infinity. And this is my new domain for the f divided by g function that we created. That's the end of combining functions. The next thing we'll look at is the composition of functions in the next video.